Everybody. I want to walk you through the homework for module number 4. And just like all the homeworks, I do solve them on my own beforehand, but I wanted to spend a little bit of time just walking you through them because obviously you're going to see it when it comes time for the exam. So, with that said, let's look at question number 1. Now, again, your numbers are going to be a little bit different, but the theory that I walk you through should be the same. So, again, my philosophy with statistics in 6 weeks as a summer class is going to be a little bit different than some of the other faculty members. That's just not a trying to compare myself to anyone. I'm not trying to make it what I'm doing easier or harder. None of that. We've got to get this done in 6 weeks. There's no point in making you suffer and holding you to impossible standards, but I also don't want to shortchange you. So, how would I, as a person, as a scholar, how would I solve this? Simply. When I approached number 1, all I did was I copied the numbers. I then put them into SPSS right here, and I just copy and pasted. Then I went to analyze. I went to descriptive statistics, and I went to frequencies. It would appear here, and I just already moved it to over here. Then I clicked on statistics, and I made sure I had my standard deviation set, my mean set, and my median set. I said continue. I said okay. And then we're going to see that it calculates out for me that the mean is 21.116, the median is 24.15, and my standard deviation is 9.588. Doing your sufficient rounding, I got it all correct. Now, you can always click on those little keys to see what the whole answer is this way. Obviously, you would know what the mathematics are for calculating these things. But again, my hope is that you're going to try to be practical about this. And if computers can do the work for you, I would prefer, from a time standpoint, you let the computers do the work for you. That's how I solved number 1. Let's look at number 2. Okay, so this one's actually not something you need to calculate because what we know is that from a binomial experiment that the probability of success is equal on each trial, meaning that the probability of success on trial 7 is the same as the probability of success on trial 3, meaning it's 0.83. Let's look at number 3. Now here, we've got 17 trials, binomial experiment again, probability of success being 0.16 on trial number 10. What is the probability of failure on trial 14? Probability of failure would be 1 minus the probability of success, meaning 1 minus 0.16, which leaves me with 0.84. Okay, let me walk you through this one. This one is the M&M question. Now, there are some easy ways to solve this. There are some hard ways to solve it. If you click these little keys here, it'll tell you what the equations are. But honestly, except for the last one, last two, I didn't use the equations because I don't want to type this into my calculator. Like, who does that? I mean, we're not ancient. So you're going to think I'm crazy here, but there are websites where you can just type in a probability calculator here. So probability of success on a single trial, you can just see I already typed this in beforehand. So we know that for in my case, the one I'm doing here, these are red. The probability of success for red is 0.12. So I put that in, probability of success on a single trial. Every time I pick up a peanut M&M or M&M, it's 0.12. That I want 4 of the 6, meaning I have 6 trials. I have 4 times how many? If I wanted to pick 4 of the 6 being red, where red has a 0.12% chance of happening. Again, stattrek.com, online calculator binomial. It's a pretty good calculator because now it's going to give me all these numbers. Now, I can use most of these numbers now to get what I want. Let's go back to the question here. What's the probability that exactly 4 of the 6 are going to be red? Yes, you could type into your TI calculator this equation. But also, I could just go over here and see that the probability is 0.0024, which I just typed in right there. It's doing the same work, it's just free. You don't have to do a thing. Now, in terms of the probability that 4 or 5 of the 6 are red, here what I need to do is I need to change it to 4, and then I need to change it to 5. I need to add those 2 up. When I add those 2 up, I get, in this case, 0.0025, right, which is our correct answer. So all I had to do here was go back to here, 4, and I can change this to 5.00013. So if I add those 2 together, I'm stuck with this, which is 0.0025, which is essentially 0. What's the probability that at most 4 of the 6 are red? Let's go back here, change this back to 4. At most 4 of the 6, so now I would want it to be I would want at most 4, so it would be less than or equal to. That's how you would read at most, and so that would be that my x is less than or equal to my number of trials. That's 0.9986, which if you do the rounding is 0.999. Probability that at least 4 of the 6, well, that's going to be 1 minus this answer, which leaves me with 0.0025. Sorry, at least, sorry. Now I'm going to be 0.9975. Leaves me with 0.0025. Now, if I randomly select, if I repeatedly select random samples of 6, how many do you expect to be red? Now I'm trying to find the expected value. The expected value equation would be number of trials, in this case 6, the probability of success being 0.12, giving me 0.72. That's just the equation for the expected value in a binomial distribution. Same with our equation for the standard deviation in a binomial distribution. That would be the square root of 6 times 0.12 times 0.88, which rounded out gets me 0.8. Now, when I looked at this a little bit further, it's Wednesday night. It's the 3rd. You've got to do this exam here in a few days. So 5 and 6, these go with the Poisson distributions, both of these. I am making the a professional decision that we avoid these. I solved it. It took me about 10 minutes to solve it. And it took me 10 minutes to solve it. So I would suspect you've got a few hours, or at least an hour, to solve it. It's not that like I can solve things 6 times faster than you. It's just I've done it enough. that means that questions 5 and 6, I'm going to get around those. Get around them, not do them. These are definitional. There's not much I can say about these, except these are the definitions of the different distributions. And that a good sample of a binomial distribution, diseases are good because you've got two possible outcomes. You got the disease or you don't. Okay, I really, really hope that helps you walk through how I solved module 4. Because again, I just want to be pragmatic about it, meaning I just want to get you through what you need to do to be able to do well on the exam, and for you to be able to do well when you get to senior project. So I'm going to leave it at that. Let me know though if you have more questions.